So hi folks, I'm Sherin, and today I want to talk about basically how we are using Acryl for data discovery for schemas, and also schemas for doing some interesting things in for discovery and governance and so on and so forth. So I'll jump right in. My name is Sherin. I'm a software engineer at Chime, and I already introduced myself, so I'm going to just skip over that. And I want to start with like just the enormity of the problem, that the problem space that we are looking at just generally, in the data world. So the data tools, these are the number of data tools that existed in 2012, so like a decade ago. And this has blown up to like this in 2021, so a decade later. And what has happened is that it's becoming easier and easier to run ETL to ingest, process, and produce data sets. But what is becoming difficult is that because of this amount of data, a lot of source of truth data, all of these things are hidden. There are duplicates, inconsistencies, there's too much data, inaccuracies, and so on. Moreover, in a lot of organizations, I've noticed that there is like Conway's law in play. So Conway's law suggests that communication patterns in an organization mirror the org structure. And in a lot of organizations, the producers, which is the product engineering, and analytics, which are the consumers of data, are in separate orgs. And there's usually a data engineer, communicating between these two and getting requirements and solving their problems. But because these two groups are not talking to each other, there are a lot of problems related to consumer expectations, producers not knowing how their data is being used, and so on and so forth. So the first thing that we wanted to do at Chime was bring all these folks into the same page, and that's where we started using Acryl and DataHub. So you wanted this to be the water cooler, if you will, where people can discuss and find what they need in a single place. And my favorite part about Acryl is the lineage, because this is one really easy way of connecting the producers to the consumers. Now the producers know who is using their data, consumers know where the data is coming from, and it is easier to have accountability mechanisms and all that in place. And we'll see that next. Now that we have a place where these producers and consumers can talk to each other, we also need a common love language or a data language for them to communicate in. At Chime, we have been very strict about schematizing our event data, raw data from the beginning. We use protocol buffer schemas to represent the data models for a bunch of things. Even for Snowflake tables, the data model for Snowflake tables that are backed by events, we create this data model in protocol buffer schemas, through which the Snowflake tables are created. So this is so basically the point that I'm trying to make is like schemas are used for everything in our world. And one interesting thing about using a programmatic schema definition language, such as protocol buffer, is all this extra surface area that it gives you to do, all these extra bells and whistles to do interesting things. So once you have schema in code, you can add documentation, so comments. And also with protocol buffer schemas, not recently, well, a couple of years ago, I think they came out with this thing called field level and message level options. And these options are basically like annotations or metadata that you can add to your schemas. They're not really sent on the wire, but they are available to add metadata. So for example, we use that to tag teams or add extra documentation. In some cases, we also use these field level annotation to classify a field. And the other thing that we really wanted to be cognizant about was how data flows through the organization. So most of the data originates in raw form, so in the form of events and logs and so on. Then it is processed by Spark and ETL workflows. Then fact tables are generated, and finally business insights, funnel analysis and dashboards are created, which is what most people, execs and leaders and PMs look at. But even though we completely abstract all these business insights away from raw data, they are not immune to issues in the raw data. So if, let's say, something goes wrong in the raw data, it may impact business insights. So for example, let's say that someone stops producing a field that is used for calculating the revenue. Now, if an exec is looking at the dashboard, they don't know whether the revenue organically dropped or it's because of a data issue. And this is why we wanted to bring everybody, connect all of these components and through lineage. So now our engineers, PMs, analysts, and BI folks, everybody is using the same tool. Engineers can add context about, like, what each fields mean. They can also add assertions to make sure they're not breaking anything that is being used downstream for driving any business insights. And they can add data quality checks. And we have been using the incidents and the validations in Acryl quite a bit. And now visibility increases because all of these people are communicating at the same tool and they have the lineage. So if someone finds that something is off in a dashboard, they can just look at the lineage and they can find, if there is any node which has an active incident there, find their owners, reach out to them. The other thing that the other learning from implementing discovery through DataHub at Chime was crowdsourcing metadata ingestion. So at Chime, and like most companies, there are many different data tools and technologies used by different teams. For example, machine learning platform owns feature store, they own models and SageMaker. There may be a different team that owns, security and compliance and so on. So having a central team to ingest metadata does not cut it. So, a pull-based metadata management does not work very well because, or it's just like a lot of work for teams. So instead, we went with the way of like a push-based, metadata ingestion, where even to like design best practices, we have this small team of representatives from different teams, like machine learning and security, data engineering, and so on. And this group of data stewards help define best practices and how to ingest metadata, and uh, have been building out the core platform. And and think of metadata ingestion like log and metric collection. It should happen right at the source. So like how log and metric collection happens as via sidecar processes and systems, that is how metadata ingestion should happening. Just collect it from the source, have it pushed down to DataHub. For that, our team, some of the brilliant engineers that I work with at Chime, they built out this central ingestion service, basically a wrapper over the DataHub API. And now all the sub teams are building their own metadata extractors that integrate with their own systems and services and push metadata to this wrapper over DataHub API. And this wrapper essentially abstracts away the data model and so on, so that the teams don't have to worry about how the DataHub API looks like. So this is how we have been collecting or ingesting metadata into the system. And this is a simple one. This is another thing that we have been ensuring or enforcing from the beginning, is that everything must have an owner, and no owner, no accountability. And for even you can add all the assertions you want, but someone needs to fix those issues. So for that, we need owners. And coming back to shift left, and we've discussed this, shift left many times throughout the course of many different talks today. So the other we kept this in mind right from the beginning. So we wanted to collect metadata at the source. So for that, as I spoke about earlier, we leverage schemas to have producers tell us the nature of their data, give us documentation, tag things, and using DataHub SDKs, we ingest all of that information as glossary terms, tags, and description into the tool. And once it is in the tool, you can run searches on top of it, find things by glossary tags, and so on. And finally, data contracts. So this has been the hot topic. Every time I open LinkedIn, I see a lot of posts about data contracts. There's a lot of opinions, and this is a very developing area in our space. But what is it? So, and this is just my opinion of how I perceive data contracts. So, in my opinion, data contracts is basically basically SLAs, like a formal agreement between producers and consumers. And it contains like three main things. So schema, semantic, and accountability. And we already talked about some of those things and how it can come together to form a data contract. So we have schemas where that defines, have some accountability around what the structure of the data should be. We can set assertions, like John just before me, he presented like this amazing way of setting assertions through DataHub that can do semantic checks. And through lineage, we can tie it back all together, have accountability back to the producers, hold them accountable for assertion failures, find when things are broken. And this is how we are organically doing it. But I'm also really excited to see the data contracts support coming up in DataHub. And that's all I have. And if you have any questions, please reach out to me. Thank you so much for having me.